I'm really bad with technology.
All right, good morning, everyone. Let's get started with our summary.
I did my math homework and my notes today.
Proud of you.
No, I did. I woke up at 6 o'clock this morning to do it.
Now I believe you.
I woke up 45 minutes early before I had to leave to go to school to do my homework. Because I got home late last night. Stupid baseball.
I got late home on Tuesday. That was it. Well, no, something happened yesterday. I can't remember what happened. But like, I didn't do something.
So do we need to do we still have to take a picture of our test, or can we just give you our papers?
You are welcome to give me your paper, but it would be easier on me if you could just put it up on Google Classroom. But it's fine to give me your paper.
Oh yeah, I want to apologize for all the bad handwriting on my notes and my homework and everything.
I appreciate that, Ariana.
I've never had the gift of penmanship.
All right, good morning, everyone. Oh my gosh, Lucia, I just started rewatching Mob Psycho 100, so that's funny that you just changed that. There's the link to the Jamboard again. All right, so 12.5 summary. Just started season 2. Nice. So what was 12.5 all about?
Learning to find the degrees and intervals. Wait, I know how to do it.
Right? And there was one kind of solution that we learned, a form of solutions.
The degree?
What did we need? Not quite degrees, but like what did we call the form of solutions? Camille's got it general.
Oh.
General solutions, which is all possible solutions to the equation. But then we look at it on certain intervals. So what were the steps for solving an equation?
Isolate the trig ratio.
Right? We're going to isolate the trig ratio.
Find the general solution.
Find that general solution. So I want to pause here. With the general solution, we have to find out what we're adding to the angles that we find. So what I mean is, right, so you said plus 360n. Is that for sine, cosine, secant, cosecant, or tangent and cotangent? Right, and why is that? Right, it's their period. One full revolution on the circle. So what would we add for the general solution for tangent and cotangent? 180. Okay, so once we find the general solution, what's the next step?
Oh, find solutions on the interval.
Right, we're going to find those specific solutions on the interval. Alright, so these are the steps we take when we are solving those trig equations. And the new thing that we learned was that general solution. We add 360n to it, because that's the period for sine, cosine, secant, and cosecant. We add 180n if we're looking at tangent and cotangent. That's the period for those two. Alright, so did anyone have any questions on the practice problems?
No, but can you post it?
Yes, I will post the link. And I will do number 2, Camille. Also, Camille mentioned earlier, for these practice problems, I didn't write the interval, which was my bad. I meant solve for theta in between 0 and 360 degrees. Nice catch, Camille. And we'll look at number 2. Which was 2 cotangent squared theta equals cotangent squared theta plus 1. Alright, so first step was isolate the trig ratio. How would I do that? Oh, I'm not presenting. Thank you. So our first step says to isolate the trig ratio. Right? I would get rid of one of the cotangents, so what am I going to do to both sides? Right? I'll go ahead and do that. So we have 2 cotangent squared minus 1 cotangent squared is going to be 1 cotangent squared equals 1. Alright, we're almost there. We don't want to consider a cotangent squared when we're solving. We want just cotangent of theta equals something. So what would we do to get rid of that squared? Square both sides?
Square root?
I would square root both sides, right? So square root cotangent squared of theta is cotangent of theta. And then what's the square root of 1? Is it just 1?
Oh, yeah.
Right, we need that plus or minus. You always want to remember to put that plus or minus when you're taking the square root, because a negative 1 times negative 1 is still positive 1. That's where that minus comes from. So we need to consider both a positive 1 and a negative 1. So I'll go ahead and write those two. So really we're looking at 2 equations. Cotangent of theta equals 1 and cotangent of theta equals negative 1. So where would we go from here? We've got to solve for theta. Right. But do we have a unit circle for cotangent?
No, you have to make it tangent.
Right. And just like Camille said, convert it to tangent. So we know that cotangent is 1 over tangent. And we'll do that to both equations. So we want to solve for tangent now. We have that tangent unit circle. So what would we do to both sides? Good morning.
Put one of the, yeah.
Right. Caleb said it, reciprocal. So 1 is the same as 1 over 1. We can write over 1 for both of these. And we would take the reciprocal of both sides. So we get tangent of theta equals 1, and tangent of theta equals -1, if we flip both sides. So now we can look at our tangent unit circle. What theta values give us a tangent value of +1? Whatever the circle says is exactly right. And Camille says we got 45 degrees. And 225 degrees. What about for -1? 135 and 315. Double check that. You're absolutely right. Okay, so what's our next step? We finally found some theta values. We got to do the general solution. Okay, so I'm going to split this into two. We're going to do it on the right side. Okay, so for the +1 theta values, we have 45 and 225. Do we need to consider both of them?
No.
Right, we only do one, as Camille said. So I'm just going to cross one of them out. We'll only consider 45 degrees. So what would be the general solution for 45 degrees? 45 plus 180n, and why are we choosing 180 and not 360? Right. And then same thing for tangent of theta equals -1. We only need to consider one of these. So we'll do 135 plus 180n for this one as well. All right, and then we need to find all the angles in between 0 and 360 degrees. So where can we start? What n can we start with?
1.
All right, let's do 1. So what's 45 plus 180? 225. Is that on our interval? All right, then we'll keep it. Should I add 180 again? No, right? Why is that? It'll be over 360. 0. Let's check out 0. What would this be equal to? Right, it'd just be equal to 45. Is that our interval?
Wait, no. Yeah, that's it.
That's it? Why is that it? What happens if we subtract 180?
Go to the negative and that'd be over.
Right. So we're done here for the left side. Now let's do the right. Which end should we pick?
0.
All right. Let's try 0. So that'll be 135. Is that on our interval?
Yeah.
It is. So we'll keep it. And then I heard you say -1, so we'll subtract 180. And what'll that give us? -45, is that on our interval?
No.
It's not, so we're not going to consider that. Regular 1? And what is regular 1 exactly?
That's +1.
+1, all right. What's 135 plus 180? I'm just going to make that a little neater. $315. Is that on our interval?
Yeah.
It is. Should we add 180 again?
No.
Nah, it'll go over. All right. So we've looked at possible solutions, and the ones we're keeping that are on our interval, we've got 225, 45, 135, and 315. Woo, indeed. All right. That was a good problem to choose, Camille, because we had that squared. So we, with those problems where one of our trig ratios is squared, when we take the square root, we have a positive and negative number to consider. So our solutions, we have twice as many solutions as we usually would. Any questions on that? Camille, you feeling better about this? And thank you again for catching that I didn't specify which interval. All right, nice. So, it is now time. Oh, the 12.5 homework. No, the 12.4 homework?
No, the 12.5 because you normally do the next homework at 5. You did 12.5 notes yesterday.
Right. So we're going to get into our groups. We'll do as many presentations as we can, and then we're going to do the quiz.
Okay.
I'm giving you like 20 minutes to do the quiz. It's really short.
I was asking so I know where to put the answer.
Right. So before we start with the 12.5 homework, actually, did anyone have any questions from the 12.4 homework? Or are we feeling pretty good about these simpler equations? 6 of these. I am more than happy to go over one. But if we're feeling pretty good about it, then we can go ahead and move on. All right then. Then go ahead and open the 12.5 homework. Google Doc. We've got 7 problems today, so we'll be doing 7 groups. Now notice that these problems, I have it in 2 parts. You're going to find the general solution first, and then you're going to find all solutions on the specified interval. Notice that not all of the intervals are the same. They're different. So we're going to consider those intervals when we find our solutions. And I will put the 4 of you in group 7.
Oh, you just wanted to like leave the
You don't have to. Okay.
You know you only have 7 problems.
Yes.
You want to get rid of group 7? So we become group 7?
You know what? That would be easier on me. The 4 of you can go ahead and leave the meet, if you don't mind. Oh, hold up. Why did it only do 5? Aw. Come on. Okay. Alright, go ahead and join your groups. I'll see you in a bit.
Ms. Millen, can you click on the little check mark and tell me who's not here today? They'll come up in pink.
Oh, that's really neat.
Tony, Arwen, and Andrew.
Tony, Arlen, and Andrew. Okay, thank you. Andrew,
Andrew
Wright.
Wright.
Or, okay. Thank you.
And then how do I minimize this little tab
Oh,
again?
just click the arrow again, the check mark
Oh,
again.
okay. Thank you.
Uh-huh.
Hey, Jesse, go ahead and join your group.
It must be Andrew Ordonez, because I don't think Wright's in this class. I see Ordonez.
And Andrew Wright is in this class.
Yeah, I had him in a group of
Oh, okay. It's because they have the attendance split up by tracks now, and so I didn't see him if he was in another track.
Oh, gotcha.
Thank you.
Yeah. Actually, I don't see Andrew O either. He must have.
If he's not pink, that means he checked in at some point.
Oh, gotcha. Okay. Sure, Sam. Let me. Let me write the numbers real quick. What do I even have to? 5, 6, 7. No, I don't have it. There you go. Nice nails.
Taylor, what's the problem?
Tangent squared theta.
What?
Tangent squared
Okay.
theta.
And then square theta
Minus 1 equals 0.
minus 1 equals 0.
And we're finding negative 180 through 180.
5. Negative what?
Negative 180
Mm.
and positive 180. 180. Oh. Okay. What do we do?
Okay, so the first thing we're going to do is find the tangent, so we're going to move the 1 over.
Plus 1, 1. And we'll make that back square root equals 1.
Then we square root both sides.
Those cancel out. So it becomes tangent x equals square root of 1.
Which is
1.
plus or minus 1.
Which becomes tan x equals plus minus 1.
Yes. And then we can write out tangent x equals 1 and x equals negative 1.
And x equals 1. And I don't like how that whole and x equals negative 1.
And positive 1, we get 45 from 225.
45 and 225?
It's the same numbers, that was number
225.
Which one is 135 and 315?
135. 315. That's me. 15. Woo!
Okay, so the general solution, well, I think the first 2 degrees, the last 2 degrees on each one don't fit the intervals.
That's
So
Ow.
we would do 45 degrees plus, plus 180n, and then 135 plus 180n.
45 plus 180 and 135 plus 180 that's 18. 80 equals
I might not be sure about this, but since it's negative 180 to 180, I don't think we would be using any positive numbers because we can't go over 180. Is that right? Okay.
so it's
we can use negative
45 and 135.
So we can put negative 1 for 180 and we get negative 135. Oh, wait, I zoomed in too fast for that. Okay, so we're putting a negative 1 at the end for the first one, so we can get our negatives, because that's the only way we can go.
Yeah. 45 plus 180 and 1, which equals
Negative 135.
negative 135.
And then we're going to do the same for the 135. And it'll equal 145. Wait, no, not 145. 45, sorry.
135 plus
See, that's always gets me on the streets. I always forget how to negative.
negative 1 equals negative 45. So, it would be 45, comma.
You still have 0.
Oh,
Yeah, it's 45 and 135. No.
Yeah, do we,
Yeah. Everyone knows what 0
Well, I
plus
don't
the
know if I
number
write it down just to show
equals.
our work or not.
I'm horrible at showing my work. Like, I forget, like, I go a little too
Negative
fast.
45. Negative 135 and 135. That's a 6. Five. Beta equals. We did it. Nice. Oh, that's very good. Thank you, Sam. What? Hello, hello. All right, let's see here.
Hello. Okay, so is there like a typo in the equation, or am I doing something wrong?
Yes, there is. Good catch. That -3 should be positive.
Oh, okay.
Yeah, that good job noticing that it's a typo because there are no angles on our unit circle that would give us 1/4.
Yeah, I got kind of confused on that.
Yeah, my bad. Thanks for catching that. Should be equal to +3.
Thank you.
No problem.
Cosine is equal to x, right?
Yep.
Okay, cool.
Wow, very nice. Ooh. Oh wait, hold up.
I think it's like for the tan and cotangent, I know it's like 180, but would it, for like secant, would it be 360?
Yeah, I think so.
Okay, thank you.
Hello, hello, group 4.
Good morning.
Hello.
Good morning. So I see you've got some great work up here. One little thing, when we take the square root, what should be in front of the square root?
The square root?
Yeah, we took the square root of both sides. We got secant of theta equals √2. And Alicia says, right, that plus or minus, you should have a plus or minus. Do you see what I'm saying?
Yeah, but would it still equal 2 over 2, radical 2 over 2?
Yes, but it would be a plus or minus √2/2. So I see
Okay.
you've got the angles for a positive √2/2. Now you need to find the angles for the negative √2/2.
Okay,
All right.
thank you.
But other than that, you've got it so far. Over tangent. Oh, group 5. Group 5 didn't catch it. Hello, hello, group 5. Destiny and Jenna. So, I see you didn't quite catch something when we reciprocaled both sides for the cotangent, or for the 1 over tangent equals 0.
Just make it from 0 over 1, and then we flip it to become 1, or it does?
Right, we would flip it so that it becomes 1 over 0, which is what?
1 over, isn't that undefined?
Yeah, it's undefined. So we're not looking at the, we're looking for the angles that give us undefined.
Okay.
Yeah. But other than that, your work that you've got here is good. It's just that we're looking for where it's undefined, not 0.
Okay.
All right, I'll leave you to it then.
Wait, I have a question.
Yes, Destiny.
So for our quiz, you said there's no solving, we're just identifying the, what is it called, the, like, verifying whatever it's called?
Yeah, the quiz is just those verifying problems.
So we are solving something?
No, it's not solving. It's not like the work we're doing today or the work we did yesterday. It's just those verifying problems where we're proving things left-hand side equals right-hand side from lessons 1, 2, and 3.
Okay.
Oh my gosh, I'm bad. $31.50. All right, okay. I don't know. See if you guys can do number 4. I think that might be the longest one.
Us?
Yeah.
Okay.
I mean, group 4's already got it, but if you guys could work on that together, that might be the most challenging one. Number 4. Did you do it already? Oh, middle bit doing right now?
I have to take my time writing it down.
For some reason, it's just I like it.
Yeah, I like it too. It's just the writing, because I'll forget to miss a step, and I'm like, wait, what'd I do?
It's just 9.27 because undefined, right?
Yeah, that's right.
Okay, thank you.
I forgot I was in that group.
If zero's one of the solutions, do you compare it?
If 0, yeah.
Did you lose something yesterday?
Yeah,
Is it with dignity?
long ago,
Samantha.
huh?
I felt that from here.
I didn't feel a thing, but it's like dignity things on the wall. Can't touch this. I lost my whiteboard.
It's right here.
Oh, it's right there. Very happy little backpack.
It is.
Welcome back, everybody. Welcome back, welcome back.
I have a hoodie that says just a girl that likes boxers. And a box on it. That's Christmas.
All right, welcome back, everybody. We'll get started with our presentations. All right, and we're on number 1, which was 8 cosine of theta minus 1 equals 3. And we're looking at this interval negative 360 to positive 360. So what did we do here, group 1?
Okay, so sorry about that. My connection's been a little off today. So what we did was we subtracted, not subtract, we added the 1 to get 4, and then we divided the 8 to get 4 over 8, and then if you reduce it, it would be 1/2. So when we checked on our unit circle, it was 30 and 300. So then we just, yeah, 4, because it would be, at first we thought it was a negative, but it wasn't a negative, it was a typo. So we got that cleared up. And then we went to the side and we did the, what is it called? We did the thingy. So we did 60 plus the 30, and then, and we got 300, or 60 for that one, and then we did 300 for the next one. And I don't really know how to explain that part, but yeah.
All right, so I'm going to pause you right there, Danielle. What do we call this thingy? 60 plus 360 in? Yep, Samantha says general solution.
Oh, okay. And then for our outcomes, we got the negative 300, negative 60, 60, and positive 300.
All right, nice. So how did we determine that we were gonna choose these values? Why do we keep all of those? Right, Samantha says they're under 360 and above 0. Well, what's our interval that we're looking at? Our interval is what determines which solutions that we're keeping. So negative 360 to positive 360, all of these solutions are within that interval there. All right, thank you very much, group 1. And we will go on to group 2 and Danielle. Thank you. All right, group 2. We had tangent squared of theta minus 2 equals 1. What did we do here? see Annalise, Danielle, and Stephanie were in this group. All right, Stephanie did the Jamboard, so Annalise and Danielle, can we explain what's going on here? All right, okay, so Danielle's mic doesn't work. Annalise, how you feel? Will you take one for the team? That's very nice of you, Ariana. Ariana is going to present for you guys. She just volunteered. Come on down.
Okay, so what we're first going to do is we're going to try to get tangent alone. So we move the 2 over by adding it to the other side, and we get 3 on that side. So to get rid of the square on the tangent, we have to square root both sides. So we get tangent theta equals the square root of 3. So looking at the unit circle, we see that the two angles that equal the square root of 3 for the tangent circle are 160 and 240. So our two general solutions are 60 plus 180, and because this is tangent, so it would be 180 as a 180 is a full period, and our next one would be 120 plus 180n. So our first one would be 0, which equals 60, and for 0 on the 120 side, it would equal 120. So the next one we did is 160 plus 180 over 1, which equaled 220, but 220 is too high for the interval, and our interval is negative 180 to 180 degrees. So that one canceled out because it doesn't fit our interval. So we tried negative 1 for the 160 solution, for the 60 solution, and we got negative 120, which fits our interval. And so on our other side, we also tried negative 1 for 180, so which equaled negative 180, and we got negative 60. So the degrees in our interval would be 60, negative 160, 60, negative 60, negative 120, and 120.
All right, thank you, Ariana. Ariana is a champ for presenting for another group. Nice work, group 2. All right, let's go on to group 3.
Okay, so our problem was negative 2 cosecant theta equals negative 3 cosecant theta minus 2. And what we did was we added 3 cosecant theta on both sides, and then we get cosecant theta equals negative 2. But we have to convert that into sine. So cosecant is 1 over sine theta equals negative 2 over 1, and then we flip that to get sine, which is negative 1 over 2. And the angles we got were, the degrees we got were 210 degrees and 330 degrees. And so we did 210 plus 360 since it is sine, and 330 plus 360 n. So we subtracted 360, we got negative 150, and then we did 0, which is 210, and we did 1, but it exceeds 300, so we didn't include that. And then for 330, we subtracted negative 1, which is negative 30, and then we subtracted 360, which is negative 30, and then another 360, which is negative 390, but that's way more than negative 200, so we didn't include that. And also we did 0, but it exceeds 300, so our final solutions are negative 150, 210, and negative 30.
Yeah, great explanation, Camille. Very clear. I like how we remembered that when we're looking at cosecant, we got to change it to sine, reciprocal both sides to solve, and find our solutions there, taking into consideration our interval. Nice job, group 3 and Camille. All right, let's go to group 4. What do we do here, group 4?
So what we did is we try to make the secant by itself. So we plus 2, then with secant squared equals to 2. And then we square root of the 2 to take out the square. And then we got secant equals square. And then we change it to cosine. And since it's square, it's both positive and negative. So we change it to 1 over cosine equals to 1 radical 2. And since the radical is not supposed to be there, we multiplied by the radical 2 times, and we got radical 2 divided by 2. And over here, we did 45 plus 180n, and we got equals to 45 because we can't go over or under 0. And then I don't think we did the 315 to 25 yet.
Okay, no problem. So we didn't finish, which is fine. I know this one was a long one because we've got to consider the positive root 2 over 2 and the negative root 2 over 2. So I want to ask, why did we choose plus 180n for our general solution?
Is it supposed to be 0?
No, it's not.
It's because it's supposed to be 360.
Yeah, could you say that again, Camille? Because it was a little...
360 because it's cosine, not cotangent.
Right. Does that make sense, group 4?
Yeah, I think we got confused versus when.
Right, yeah. For our general solution, since the period of cosine or secant is 360, we should be adding 360n for our general solution.
Okay, so the 0 and 180, that's just the limitation. That's just the boundary lines. But you still use 360?
Yes. The 0
Okay.
to 180 is our interval. That's where our solution should be, in between those two angles.
Okay, cool.
All right. So yeah, just a little fix there. We would replace that 180 with 360, and then we would get different solutions, but we keep the ones that are in between 0 and 180. All right, thank you, group 4. And now on to group 5. What do we do here?
So we had 3 cotangent equals 2 cotangent. We would subtract 2 cotangent on each side, so it's just left with cotangent equals 0, and we would change the cotangent to tangent, so it would be 1 over tangent, and we have to do the reciprocal of that, and we're left with tangent equals 1 over 0, and that's undefined, and the undefined angles are 90 and 270. So for the boundaries thing is from 0 to 360. So we did the 90 plus 180 is 0, which is 90, and 90 plus 180 times 1, and that's 270. And then if you multiply 180 by 2, or -1 added with 90, that goes over the boundaries and under the boundaries. And then for 270, we do the same thing, 270 plus 180 times 0, which is 270, and 270 plus 180 times -1, and that's 90. And if you try to do 1 or -2, it's under or above the boundaries.
All right, yeah, thank you, Jenna. Nice explanation. So I notice here that we got the same solutions, 90 and 270, for both from the general solutions. Why is that? Why did we get the same solutions?
You're the only undefined angles, I think.
Right. 90 and 270 are the only undefined ones, but notice that when we looked at several different solutions from our general solutions, 90 plus 180n and 270 plus 180n, we got the same numbers, 90 and 270. So remember, when we are working with tangent and cotangent, we only need to consider one of the solutions from the unit circle. But you are correct that those are the only two undefined, so if we're looking from 0 to 360, those are going to be the only two angles. Nice job with that. All right, thank you, group 5. And group 6, what do we got here?
Alright, so our problem was 50 sine of theta minus 10 is equal to 30 sine of theta. And then you can basically just subtract the 50 to the other side, and you get a negative sine of theta. And on this and on the other side, you're left with negative 10. And then when you divide by 20, you basically get 1/2, negative 1/2. I mean, the negative signs cancel, so you can divide through 1/2. So when you work on the unit circle, you get 30 degrees and 150 degrees, and then so you basically just take the 30 and then add 360, and then like if you if you do 30 plus 360, you get 390, which is over. But yeah, if you do 30 plus 360, and there's like a 0 in the parentheses, you get 30, which is in between the range. And then if you do 30 plus 360, and it's -1, you get negative 330, which is still in range. And then that's it for like the 30 degrees. And then if you do 150 degrees, you do 150 plus 360, and then it's like a 1 in the parentheses, you get 510, which is over the range. If you do 150 plus 360, it's a 0. In the parentheses, you get 150, which is in range. And then you do 150 plus 260, and it's -1. You get 210, which fits in the range. And like the total is 30. Negative 230, negative 210, and 150.
Yeah, thank you, Nelson. Yeah, nice job going through each of these solutions and determining which ones that we got to keep on our interval. All right, nice work, group 6 and Nelson. And group 7. All right, thank you.
Brian, it's your turn.
I just did it for another group.
Well, I can help you out, Ryan. We can go through it together.
Yeah, Brian.
I know Ariana presented for another group. Caleb has presented. Samantha wrote it.
Your turn.
Oh, yeah. Wow. All right, Brian, actually, you're off the hook because it's time to take our quiz. That was really close. Okay. Next time, Brian, I will remember. All right. Thank you for all of the groups who presented today. We're going to get started with our quiz now. So go ahead and turn on your cameras, prepare your workstation. I'm going to put the quiz up on Google Classroom.
Will we have to use Circle for this one?
Yes.
Okay. So, yeah.
Oh, wait. Sorry. No. These are verifying problems, not solving.
I already felt the figures.
My bad. My brain was stuck on solving, so I was like, yes. Okay.
I don't think having to set up the camera though. Like I have formal posture, but having to look at this, that makes it does not make it better.
You need to be back on the meet. I don't
No, we don't.
No, you can leave the meet.
She can just look at us here.
That's right.
So we don't have to. Oh, dang. We'll never have a test on a Wednesday, right?
Right.
Like a real test, not like the quiz.
Right.
Okay.
Probably not.
Probably.
Probably not. Most likely not. All right, the Unit 12 quiz is up at the bottom of week 17. Go ahead and open that PDF. So it says verify each of the following equations. Show your work as we've done in class. Remember to label the left-hand side and the right-hand side. I want to see that in your work. All right, but other than that, everybody, work hard, do well. Once you're done, you are free to leave. Except you guys, you got to stay. How do I stop the recording, Mr. Bailey? Is it here?
Pause button should be. Sometimes that thing hides. Let me see if I. Oh, click on the little frame.
This thing here? The frame?
Yeah. And drag it down a little bit. Keep going down a little bit more, maybe. There, it's hiding behind the taskbar. Let me help you out just.